Okay, how to sum up free body diagrams. We add these all things up, all right? You're gonna have the up and down part and the side to side part. All right, so what we're trying to do here is we're trying to figure out, we're gonna try and add the up and downs together and the side to sides together to see if they add up to 0 or if they add up to not 0, right? And if they're not 0, then you're gonna be accelerating. And if they're 0, there's no acceleration, constant speed. So here we go. Pushing a box horizontally along the floor with friction, causing it to speed up. All right, because it's speeding up, I know that the forces are not equal to 0. All right, it's unbalanced. What we're going to do again, though, is we're going to look at each direction differently. We're going to look at the force in the x direction. And we're going to look at the force in the y direction. All right, so as we look at this, draw a free body diagram. Here's the box. Gravity's pulling it down. Okay, the normal force is pushing it up. All right, and then you've got your push. Right, and that's your applied force or whatever. And then you have the force of friction. And one thing to note is that it's speeding up, so this side needs to be bigger than that side. So if we start summing things up, we see that the y direction has a normal force up minus gravity down, and I know that that is going to be equal to 0, okay, because there's no acceleration that way. All right, the f of x, though, has a force forward, the applied force, and then you subtract off the friction force backwards, and if you add those two together up, they are not 0, and so you have some acceleration. Okay, that's how we would draw this. This is how we'd sum up the parts of this picture here. So what you're doing, right, to find these sums, you're going to draw your free body diagram, decide which way is positive, which way is negative. The way it is moving, make positive, okay? Whatever way it's moving is positive. It's going to be easier, all right? So if it's on a ramp, positive is down the ramp, say. If it's falling, okay, we'll make positive downward, all right, just so we have a system. Then we're going to look at the x direction, we're going to look at the y direction, we're going to see if there's 0 in each of those, okay? If it's at rest, boom, it's 0. If they're constant, anytime you see the word constant, that's 0, right? 0 unbalanced force, 0 extra force. You add up the forces, there's 0. But if the velocity is changing, then it adds up to something not 0. And we'll just put not 0 for now. What we're going to do is we're going to list everything in the x direction, then we're going to list everything in the y direction. Sometimes, if something's at an angle, we're going to break it into pieces. Right? If it's off angle, I'm going to break it up to an x part and a y part. Okay? And if it's 0 in one direction, then it's going to be equal to 0. Okay? If it's not 0 in a certain direction, we're going to set it equal to ma, right? Because ma is mass times acceleration. And so you will have some force causing acceleration. So instead of just saying not 0, we're actually going to say ma. We'll use that in our math later. So here's our car, right? We have a force down, force forward, a force backwards, force upward. All right, and we know that this is plus because that's the way the car is going. Constant velocity, right, means that all the forces add up to 0. Okay, so here's, say, an applied force. There's friction. There's the gravity force and the normal force. And so we would say side-to-side forces, okay, the sum of them is going to be the forward force minus friction. I can't get it, I lost it, friction. Okay, and the sum of the y's is going to be the normal force, that's F of n, sorry, minus gravity. Okay, and both of those are going to be equal to 0. I ran out of space. Both of them equal to 0, those sums. All right, a turtle falling out of the tree. Okay, this is really easy. The only force on a turtle is gravity if it's falling out of a tree. So then we say the sum of the forces in the x direction are 0 because there are none, and the sum of the forces in the y direction are not 0. So I'm going to put in ma. Oh, and actually I should have said the actual forces are f of g, and then that is equal to not 0, so I'm going to put in ma. All right, try another one. Here's a car slamming on its brakes. I already got the arrows in there. Okay, so this is friction. This is normal force, right? This is gravity. All right, and we see that if we sum up all the forces in the y direction, that's going to be the normal force minus the gravity force. So you can see the pattern coming on here. And that is going to be equal to 0. There's no extra force. It's no unbalanced up and down. However, we add up the x forces. All we have is a negative force of friction. And we're going to say that is equal to ma because it's not equal to 0. Okay? Here's an archer. Check it out. It is the same thing. The arrow in the field is the same thing as the turtle falling. Anytime you have projectile motion, it's going to be just like this turtle thing here. Okay? All right. Something in the y direction, but nothing in the x direction. All right. Here's the more complicated one. So the turtle is sliding down the hill. All right. So this is the positive direction, and the negative's up this hill. If I do a normal force now, okay, that is technically going to be our y direction. Okay, plus y, because this is our x direction, and this would be perpendicular. So if we then go to gravity, all right, and then at constant speed, there's going to be friction. So this is the opposite way we're going. What happens is if we sum up the y direction, right, you're going to have f of n minus something, the downward part. The same thing in the y's. We sum up the in the x's this way. You're going to have something minus friction. Okay, and they're all at a constant speed. So whatever this is going to be equal to 0. Whatever this is going to equal 0. What we do is we're going to break down gravity into an up and down part and a sideways part. The most important thing to remember is that this here is a right angle, which means that there is a hypotenuse. Hypotenuse. So this is the longest side. We want to break this down into pieces. Turns out that this side is the angle of the tree of the hill, and so this side is going to be sine, right? This side is going to have cosine of that angle, and so if we get here, what we're going to have is for the y part here, the f of normal minus, that'd be this here, the cosine of theta times the hypotenuse, whatever that is, f of g cosine theta, and that equals 0. For f of x here, right, that's the friction one way, which is negative, and the sine of theta times again the hypotenuse, which is the force of gravity. That is my positive force down the hill, and this is the negative force. All right, so what we can do is we can break down this gravity into a side up and down and a side to side in our new sort of direction, and we can put it into our f of y and our f of x. And both of those should be equal to 0. So you see that f of n minus this is 0. Well, that means these two are equal. And over here, this junk here minus friction is also 0. So these two are going to be equal. All right, we'll do more and practice this.